So, good morning students. Yesterday what we were discussing? We were discussing about the concentration terms. In concentration terms, I think we are discussing about the molarity. In molarity also, we are discussing about the dilution of a solution. So, let me revise for the dilution of the solution. Means yesterday I have taken one example that if I having 100 ml of solution that contains 2 moles of NaOH. So, if I add some more amount of the water in that, so does the number of moles of sodium hydroxide will increase inside the solution? No. Means we are just adding water in it. So, number of moles of sodium hydroxide that will remain same after the dilution also. So, number of moles of solute before dilution and the after dilution will remain same. Is that clear? So, dear student, we are that is what we are discussing. We are discussing about the dilution of solution. So, I told you in dilution of solution, number of moles of solute, that is M1, V1. This is what? This is before dilution is equal to what? Is equal to M2, V2, and this is after dilution. These are the number of moles of solute. Here one stand for before dilution, molarity before dilution, and M2 stand for molarity after dilution. It's not solute and solvent here. So, dear friend, I am taking one example here. For example, if here is 100 ml of HCl solution, 100 ml of 0.1 molar HCl solution. HCl solution is diluted. This is diluted to 1000 ml. 1000 ml means 1 liter. So, what will be the molarity of the new solution? So, then we have to be calculate molarity of new solution. You got my point or not? So, my dear student, please tell me what is M1 here? M1 is molarity before dilution. That is equal to what? 0.1. And what about the V1? V1 here, that is the volume of solution before dilution. That is equal to what? That is equal to 100 ml. Now, dear student, M2. M2 is what? Molarity after the dilution. That we have to find out. That we have to find out. And V2, here is V2. It is diluted to 1000 ml. So, what I told you that number of moles of solute before dilution and after dilution, that will remain same. So, here we have, I am writing once again, M1 V1 is equal to what? That is M2 and V2. Here is 0.1 into what? Into 100. M2 we have to find out into what? Into 1000. So, dear student, here is we have M2 is equal to what? That is 0.01 molar, or you can say that is 10 raised to power minus 2 molar. So, dear student, please tell me, is it clear or not? What I am telling you, that is number of moles of solute before dilution and after dilution will remain same, because we are just adding water, solvent in the solution. So, number of moles of solute will remain same. Dear student, now one more question I am taking here. Question number 2. Question number 2 is that here is, you please write question with me, that is what volume of water must be, that is must be added to 100 ml of HCl solution whose pH is 1 to make it its pH 2. So here is a question. We have a 100 ml of HCl solution whose pH is 1. We have to be add certain amount of the water in that in order to make its pH is equal to 2. So dear student, here I am writing, we are given with pH. pH is equal to what? What is the pH before dilution? That is equal to, good morning sir, Acha, remain same. Okay, you are responding. So my dear student, pH is equal to what? 1. And you know, we can calculate the molarity of the solution from the pH. So molarity of the solution is equal to 10 raised to power minus of pH. So dear student, this M1 is equal to what? 10 raised to power minus 1. Got it or not? This is molarity before dilution. And what about the volume? Please tell me. Volume V1 is equal to what? Is equal to 100 ml. Now dear student, after dilution, we want pH is equal to what? 2. Means what will be the M2 after dilution? That is equal to 10 raised to power minus of pH. 10 raised to power minus pH is equal to what? That is 10 raised to power minus 2 molar. Please tell me, is it clear or not? My dear student, that is M2 after dilution. Now we have to find out V2. What will be V2? Now we have a formula. What formula we have? Please tell me. Once again, I am telling you. Formula is that number of moles of the solute before the dilution and the after dilution, they will remain same. So dear student, here we have, here is M1 V1 is equal to, that is M2 V2. My dear student, here 1 and 2, these are not solute and solvent, these are molarity before dilution and molarity after dilution, volume before dilution and volume after dilution. So my dear student, we have here is 10 raised to power minus 1 into what? Into 100 is equal to M2, that is 10 raised to power minus 2, and ultimately we have to find out V2. So dear student, here is V2 from this one, V2 is equal to 1000 ml. Now is this the answer? No dear student. In question, if you will see, I am writing here question. Question is what? What volume of water must be added to the 100 ml? So dear student, please tell me. Now we have V1 is equal to 100 ml, V2 is equal to 1000 ml. So tell me, what will be the volume of water that you have added? That is equal to 1000 and minus of what? Minus of 100. That is equal to 900 ml of water we have added in the solution to make its pH is equal to 2. So dear student, please respond. Is it clear or not? Dilution. Dilution means addition of water. Okay, addition of water in the solution and number of moles will remain same. Now dear student, after that, mixing of solution. Here I am writing mixing of 2 or more solution. What we have here is, that is mixing of 2 or more solution. 2 or more solution. So what we have here, I am writing equation. mixing of two solution, then M1 V1. M1 V1 is what? Number of moles of any one component plus that is M2 V2 is equal to what? Is equal to MR, and V is what? V1 plus V2. So are you understanding this point or not? We have a two different solution of the two different components, or maybe of the same components, same substance. But these are the two different solutions. When they are mixed, they will form a solution. Okay. And this will be the molarity of the resulting solution. So here I can write molarity of resulting solution is equal to what? M1 V1 plus here is M2 V2 divided by V1 and plus V2. Is that clear or not? I am taking one simple example. Try to understand that. For example, here I am taking if that is 100 ml of 0.2 molar HCl solution. HCl solution. My dear student, are you attentive? Solution is mixed with, this is mixed with 900 ml of 0.4 or 0.1 whatever HCl solution. So what will be molarity of resulting solution? So what we have to find out, or instead of molarity you can say, so what will be molar concentration of H positive in final solution? In final solution, how many solution we have? We have here two solution, one having molarity 0.2 and the second having molarity 0.1. So dear, I am writing here whatever the data is given with me, I am writing that. So what we have, M1, M1 is equal to 0.2 molar. And what about the V1? V1 is equal to what? That is equal to 100 ml. And here is M2, second solution. Second solution is equal to 0.1 molar. And what about its V2? V2 is equal to, that is 900 ml. So please respond me. Is it clear or not? My dear student, what I am telling you, we have two solution of hydrochloric acid and they have the different molarity and they are mixed to each other. Their different volume are mixed to each other and we have to find out. So here is, I told you, molarity of the resulting solution is equal to M1, I am writing directly M1 V1, that is equal to 20 and plus here is, this is 90 upon what? Upon this is 100 and plus of 900 ml, 1000, that is 110 divided by what? Divided by 1000 is, this is equal to what? That is equal to 0.11 molar. That is the molarity of this new solution. Is that clear or not? Please tell me, respond me. So then I will write the next question. Here, how many solution we have mixed? We have mixed here two solution, same solution. So dear student, now here I am taking, if there is a mixing of three solution, okay, if we have, here is what? Mixing of three solution, that is three solution. Then what will we write? I am writing here molarity of the resulting solution is equal to what? M1 V1 plus M2 V2 plus M3 V3 upon what? Please tell me. Here is V1, V2 and plus V3. Is that clear? Same formula. Instead of the two solution, here we have three solution. What I am taking here, I am writing here To understand this concept, I am writing one simple question here. That is question number 3 or 4. Here is 200 ml of 0.1 molar HCl, then 400 ml of 0.2 molar HNO3 and 400 ml of 0.4 molar HNO3. They are mixed. What will be molar concentration of H positive ion? Molar concentration of H positive ion in final solution. My dear friend, please tell me how many solution we are mixing here. We are mixing here 3 solution. Okay. Now I am writing here. Here is M1. Please write for M1 is equal to 0.1. And here is V1 is equal to what? That is equal to 200 ml. M2. What is M2 here? That is equal to 0.2 molar. And what about the V2? V2 is equal to 400 ml. And then third one is also nitric acid. Here is M3. M3 is 0.4. And here is V3. That is also 400 ml. So confirm. Is that clear or not? How many solution we have here? We have 3 solution. Now dear, here is molarity of resulting solution is equal to 20. Is that clear? If I multiply these two, that is equal to what? 20 and plus. If I multiply this, that is 80 and plus. Here is, if I multiply this, 160. Here is 160. So, dear student, upon what? Total volume. Total volume is 200 plus 400 and plus. Here is also 400. So, that is equal to 260. No one is responding. Please tell me what will be molarity of the resultant solution. Please write in the chat box. Okay. So, here is only one student is responding, that is 0.26 molar concentration. That will be the molar concentration of H positive. Very nice. Tommy, you are also responding. So, dear student, one thing that I want to be mention you here, look at that is very important in this question. What we have taken here, all 3 solutions are acid. Here is, in this HCl solution, there are the H positive. In nitric acid solution, there is also H positive. In third nitric acid, that is also H positive. Means there is a mixing of H positive. H positive is coming from HCl solution. H positive is coming from nitric acid solution. H positive is coming from, are you understanding what I am saying? So dear, when they are mixed together, then there is addition of H positive ions. Now, let me take another example. Here is question number 2 or 3 or 4, whatever is that. Here is if what we have, that is 100 ml of 0.2 molar NaCl solution. NaCl solution is mixed with, this is mixed with 400 ml of, here is 400 ml of 0.4 molar NaOH solution. Now look at here. We have what we have here. Here is first solution is sodium chloride and second solution is NaOH. When this HCl, when this NaCl, dear student, you're talking to each other and it's distracting to me. So please be focused on the chemistry only. So my dear friend, what I'm telling you here is NaCl and plus second one is which one? NaOH. Now when they are mixed to each other, addition of which ion will take place? You will write here is Na positive and plus Cl negative and they are added with Na positive and plus OH negative. You are understanding or not? My dear friend, here in both the solution, which one is common? Sodium ion is common. These are mixed. Is that clear or not? So mixing will take place. Mixing of which one ion? Na positive. Is that clear or not? I think very common. Got it or not? Means if I have a one container that contains a coin of gold and coin of silver, and the second container I have a coin of gold and coin of copper. So when they are mixed to each other, addition of which coin will take place? Addition of gold coin, because gold coin are common in both. Am I clear or not? But dear student, so mixing of which one ions will be there? Sodium ions. And what will be for the chloride ion? There will be dilution of chloride ion. If you will say yes, then I will move further. Because dear, chloride ion is present in which one solution? NaCl solution. When they are mixed with the sodium hydroxide solution, we will not get any chloride ion from the sodium hydroxide solution. So there will be dilution of chloride ion. In the same way, what will happen to the hydroxide ion when they are mixed to each other? You will write on the chat box, then I will move further. I am telling you, when these two solutions are mixed, there will be addition of sodium ions. There will be dilution of chloride ion. And what about the hydroxide ion? My dear student, there will be dilution of hydroxide ion. Am I clear? So dear student, I am writing here. Now first of all, question is what? What will be the, here is, what will be concentration of Na positive, concentration of Cl negative and concentration of OH negative ion in final solution. In final solution. Please dear friend, tell me, you got the question or not? We have a two solution here. One solution is of NaCl, second solution is of NaOH. When they are mixed to each other, there will be addition of sodium ion, there will be dilution of chloride ion, and there will be dilution of hydroxide ion. Please tell me. So dear student, when we have to find out molar concentration of sodium ion, okay, here is I am writing molar concentration of Na positive sodium ion. So for sodium we will apply dilution, we will apply addition, that is equal to what? Here I am writing 100 into what? 0.2 plus next one is what? 400 into 0.4 and total volume is what? 500 ml. Is that clear? We are applying for which one only? That is for sodium ion. So dear, here is 20, here is 160 I think, and divided by which one? Divided by 500. That is equal to 180 divided by which one? 500. So you can calculate molar concentration of which ions? Sodium ions. What for? So please, and what for? Molar concentration of chloride ion. Here is, I am writing for these, here will be dilution. I am sorry, there is addition. Yes, here is dilution. For dilution, what will we apply? M1 V1 is equal to M2 V2. So initially M1 is what? That is 100 ml. Molarity is what? 0.2. Are you understanding the question or not? Please tell me. Okay, I am telling you one solution is sodium hydroxide and the second solution is sodium chloride. So dear student, here is, now will you tell me V2, and what will be the final volume after mixing these two solutions? That is equal to what? 500. So dear, here is M2. M2 is equal to what? 20 upon 500. 1 upon 25. Okay. Molarity of the chloride ion. So let me ask you, if we have to find out molar concentration of OH, so dear student, molar concentration of OH, they are going to dilute. They are going to dilute. So here is for dilution, M1 V1 is equal to M2 V2. And will you tell me what will be the M1 for this one? M1 will be 400. Here is 400 is volume, sorry, but M1 is what? 0.4. Here is 0.4 into M2 that we have to find out. And will you tell me what will be final volume after mixing these two? That is 500. So dear student, here is M2 is equal to 160 upon what? 500. This is molarity of OH ion in the final solution. So please respond. Is it clear or not? My dear student, what I told you, here is a mixing of how many solution? Two solution. One is sodium hydroxide, second is sodium chloride. So addition of sodium will be there. And what about the chloride ion? Dilution. Let me take now, let me take one example of here I am taking. Here is I am taking 0.1 molar HCl solution. This is important, but try to understand. 0.1 molar HCl solution. My dear student, here is HCl. When this HCl is dissolved in water, here is H positive and plus Cl negative. What is the molar concentration of H positive here? HCl is here 0.1 molar. What will be molar concentration of H positive? 0.1, and here is 0.1. Are you understanding or not? So my dear student, if I am taking here, now there is 0.1 molar H2SO4 sulfuric acid. Dear student, here is H2SO4. H2SO4 it ionizes to give you 2H positive and plus SO4 and 2 negative. Now please tell me, what is the molarity of the sulfuric acid? Molarity of the sulfuric acid is 0.1 molar. May I ask you, what will be the molar concentration of H positive? From the one molecule of sulfuric acid, how many H positive are ionizing there? 2 H positive. So dear friend, molar concentration of H positive will be, you can write like this one, 0.1 into 2. And what will be molar concentration of sulfate ion? This is 0.1 molar only. Please, yes, you got it or not? So in the same way, if we have, here is 0.1 molar H3 and PO4. So I am writing here, in this solution, molar concentration of H positive is equal to what? 0.3 molar. And molar concentration of a phosphate ion, there is PO4 and 3 negative. What will be molar concentration of phosphate ion? Got it, sir? Okay. That is equal to what? 0.1 molar. Am I clear? So let me take one more example. If I am taking here 0.1 or 0.2 molar sodium sulfate, here is sodium sulfate. Please tell me, what will be molar concentration of Na positive here in this solution? Please tell me, dear student, write 0.2 molar is the concentration of sodium sulfate. How many sulfate? How many sodium ions? 2. Here is 0.4 molar. And what about the molar concentration of sulfate ion? Please tell me. Is equal to, please respond for that. Yes, you written. That is 0.2 molar. This is the molar concentration of sodium ion. This is the molar concentration of sulfate ion. In the same way, I am taking here 0.1 molar aluminium sulfate, Al2SO4 and whole thrice. Please write molar concentration. You will write in the chat box. Here is aluminium 3 positive. And what will be molar concentration of SO4 and 2 negative? Please write. Dear student, this is for 0.2 molar and this is 0.3 molar. Sir, in offline class, you will continue. Okay, we will discuss about that later. Right now, just focus on the question. Now, dear student, for that mixing, I would like to take one more example for that. Here is question number 5. Rather, you will solve yourself. What we have here is, I am taking that is 200 ml of 0.2 molar NaOH solution. NaOH solution is mixed with 300 ml of, here is 300 ml of 0.1 molar sodium sulfate solution. What will be molar concentration of Na positive ion in the final solution? What will be molar concentration of OH negative in the final solution? And what will be molar concentration of SO4 2 negative in the final solution? Now you will respond for that. Now tell me, if I am asking you about the, just tell me where there will be addition or where there will be dilution. What about the sodium positive? Respond please. For the sodium positive, it will be addition. For the sodium positive, it will be addition. And for OH negative, here is OH negative. What about the OH negative? Very nice. There will be dilution. There will be dilution. And what will be the molar concentration of SO4 2 negative? Here it will be dilution. For addition, what we have? Here is Mr is equal to M1 V1 plus M2 V2 divided by V1 plus V2. Are you understanding the formulas? What I am saying? And what about the dilution? If we have to find out resultant molarity, M1 V1 is equal to what? M2 V2. Here 1 and 2. Once again I am repeating this point. 1 and 2 are not solute and solvent. These are molarity before the dilution, volume before the dilution. Here is after dilution. Here is before dilution and here is after dilution. So my dear friend, please respond. Is it clear or not? Please respond. Is it clear or not? So now I will move to the second definition of molarity. Second definition of molarity means I will write here. I will ask you. I will quote example like this. If we have a, for example, I am taking any 5% weight by weight NaOH solution having density, please have your attention, having density of the solution is equal to what? 1.2 gram per centimeter cube. Then we have to calculate its molarity. First of all, tell me, question is clear to you or not? I am writing here. What we have? We have 5% weight by weight NaOH. First of all, tell me what is meaning of this 5% weight by weight. This means 5 gram of NaOH is present in 100 gram of solution. Confirm me this one. Is that clear or not? Okay. So, dear student, this is mass of the solution. But ultimately, for molarity, we need mass or we need volume? We need volume. So, how we will calculate the volume? Here is 5 gram of NaOH is present in 100 upon density. Tell me yes or no. Density, whatever is the density, D, I am writing here D. Whatever is given in the question is D. ml of the solution. Confirm me please, yes or no. Is that clear? Means mass has to divide with the density in order to we have a. Now, dear student, we have mass of solute, we have volume of solution. So, can we find out molarity? We need only these two things. I am writing here. Molarity is equal to mass. This is 5 gram upon molar mass. You got it or not? And divided by volume of solution is 100 upon what? Density, and has to multiply with 1000. Maybe you are understanding or not. Got it? Yes, very good then. These are the number of moles. This is volume of solution in milliliter, and then we have to multiply with which one? 1000. You got it or not? So dear student, now let me write in the formula, this in the form of the formula. This 5% weight by weight is the percentage of solution. Please, I am just making formula, try to understand that. Here is X. X is the percentage of solution. X is the percentage of solution into D. D is the density of solution in gram per centimeter cube. Okay? Into what? Into 1000 upon M2 is molar mass of solute. M2 is molar mass of solute. And here is 100. So this will cancel out. And you have X into D into 10 upon what? Upon M2. This is molarity. This is molarity. Is it clear or not? No. I am quoting one example. I am writing here once again. You can write here second definition of molarity is equal to what? X into D into 10 upon M2. X is weight by weight percentage of solution. D is density. M2 is what? That is molar mass of solute. My dear student, important one. So many times question related to this one are there in NEET. So, for example, I am quoting one simple example. After that, we will explain about that. For example, if we have a 49% weight by weight H2SO4. Now you will solve. Annoy? That is weight by weight sulfuric acid has density 1.5 gram per centimeter cube. So calculate molarity. Calculate molarity of the solution. Molarity is equal to X. Percentage is 49. D 1.5 into 10 upon 98. You got it or not? Please tell me. Only one student is responding. 1 upon 2, 15. That is 7.5 molar. Is that clear or not? Okay. So what I told you about the molarity. Number of moles of solute dissolved per liter of solution. Is that clear? Then we apply this molarity on dilution. Dilution, I told you, addition of solvent. So number of moles of, since we are adding solvent only, number of moles of solute will remain same before dilution, after dilution. Then we apply this molarity in mixing of two or more than the two solution. Is that clear or not? If there is a mixing of same types of solution, HCl in HCl, then there will be addition. If we have a addition of two different types of solution like NaCl and NaOH. So dear, I told you there will be addition of sodium ion. There will be dilution of chloride ion. There will be dilution of hydroxide ion. You got that point or not? Now we calculated this molarity from the mass percentage of solution. If we are given with the solution whose mass percentage is given to be, we can calculate its molarity. So one or two more definition regarding the molarity are left. We will discuss it tomorrow. That is relation between the molarity and the molality, then the relation between the molarity and mole fraction. Got it, student? So thank you very much everyone, and bye.
Hello, good morning, all of you. Good morning, friends. Can you hear me? If you can hear me, please reply. And today we will see some more one more topic, that is a talk. I will discuss a little bit about it. And we will try to learn more and more about the talk. Try to stick with me and focus on the board and with my words. Definitely it will help you to get some good marks. And torque is also one of the important topic every year from the rotational mechanics. That means system of particle and rotational mechanics. That's the one chapter in the mechanics. That's the heart of the chapter, heart of the, we can say, complete physics. That is one of the important chapters, the rotational mechanics. From that we found we can see the almost two question every year. Okay, and we can find on every year or every alternate year from one question from torque or angular momentum. So for today's class I will focus on only torque, and we will see how to see the torque, what is the meaning of the torque, how it is utilized in our daily life, and how it is useful, we can see there. Okay, so now yes, everyone please reply. Other people also, they are in class, please reply it. Okay, when you reply, definitely I will be encouraged from your responses, and that would be good for the class. Okay, can you hear me? Good. Dinesh, Vicky, Swami, there are all other people also in a class. Please reply it. Just try to focus. Okay. Now I'm starting the one topic, that the talk, and try to listen. Try to understand how to go for it. We call torque, or one more term we are using, the moment of force. That the one simple term we are using is torque or moment of force. It is generally denoted by tau. Okay, it's a vector quantity, and we write the first, it's a mathematical expression, then we will go for a detail about it. The tau is equal to r cross f vector. So this is the r cross f vector. This is the what, very simple we are writing it. This is a torque. Okay, when mathematically I am writing it, or we can say one thing about it, that torque is equal to r into f into sine theta. From the cross product we can see the r into f into sine theta. This is a very simple thing, we can write it to calculate the magnitude of the torque. Similarly, I can write like this also, r in tau is equal to r sine theta into f, or we can say r perpendicular into f. This is the one of the important result for this torque. The next we can say the tau also can be written as r into f sine theta. Okay, and that is equal to r into f perpendicular. We can write like this. This is a very simple thing, we can understand. Okay, this is the torque. Torque can be written in this format also. So according to the question we can see how to write this torque and force and r position vector are related to each other. Now try to understand. Suppose if I say there is a one point is there, I am taking this is the O. From this O at r position, this point is P. At this position, if this force is acting here, suppose this force is acting, okay, and this is the r vector and this is the force vector. So we want to calculate what is the torque about O. That is our intention. So what is the meaning of torque about O? So for that we have to understand this cross product part. Okay, so cross product, so I am giving little idea. Everyone know already about that cross product. I will write it, you will understand. I am just revising for you and you will understand for that how to put the cross product. Just say, suppose there is a one A cross B vector is equal to, if I say C vector. A cross B is equal to C vector. That means C can be written as A into B into sine theta, we write, or one more term I write, the n cap. What is the n cap? I will tell you, don't worry about it, you will see from it. Suppose the other one vector is A vector, this is the B vector, and this angle is theta, this angle between them, and we want to calculate what is the C, then C would be, actually we have to write their magnitude first. So what is the magnitude? Magnitude is the A into B into sine theta, and the second term is the n cap. What is the n cap? N cap is the nothing else, it is a perpendicular vector or normal vector that is perpendicular to A vector as well as B vector. That means what is happening, this n cap, or we can say C vector, is perpendicular to A vector as well as B vector. Both are perpendicular to each other. That means A is also perpendicular to C, B is also perpendicular to C. That means C is the perpendicular to A as well as B. Or we can say C is perpendicular to the whole plane in which plane A vector and B vector lies. Listen carefully, I am repeating myself. The C vector would be perpendicular to A vector as well as B. If A and B both lie in this board plane, that means C should be perpendicular to this board. It may be outside or may be inward, we will see about it, but it would be perpendicular, we have to understand up to here. It is clear to everyone? Please reply. Please reply. It is clear to everyone, beta? Good. Anaya, Dinesh, Carrie, Vicky, Tommy, other people also take part into the chat box. You are very fluent in chat. I know that part. Okay. It's a new generation. Okay. Now listen carefully. Now we have to find the C vector, direction, n cap. We want to find how to calculate the n. That means A to B. We have to go. So right hand thumb rule we have to use it. This is the right hand. This is my right hand. A to B. I'm just crossing it. Then thumb is outside. Then thumb is outside. That means this n cap or the C vector would be what? Outside this plane. We have to understand this thing. Okay. Outside this plane, that means n cap is nothing else outside the plane. Outside the plane, if I writing it, you will see outside the plane, that means we put the dot. If it is inside, then we write for inside. What is the symbol? Inside the plane, that's the cross. We use cross symbol. These are two symbols we generally use it. Now try to understand one more thing. You will focus on this. That means C vector is perpendicular to R vector. Sorry, A vector actually. As well as C is perpendicular to B vector also. That means C is perpendicular to A as well as B. Both, it is perpendicular to both vectors. This is the beauty of this. And one more thing, if it is given in the form of vectors, I will show you. Suppose A is given to you I cap plus J cap plus K cap. I am writing very simple relation. That the B is given to you, suppose 2I cap minus 3J cap plus 4K cap. If it is given to you, we want to solve what is the C vector. So we know the A cross B is the C. So to find or to calculate the C vector, we have to put one determinant method. Using that, we have to calculate it. Okay. Now listen carefully. Actually this is just a YouTube class. It will not, in the normal classes you will see from scratch we will start. Okay, from starting we will start. Don't worry about it. So try to stick with the YouTube. It will be help you to understand when you are sitting in the class, when your teacher will be teach you. Definitely it will help you because you already know the concept, how to apply this concept in different questions and different types of problems. Okay, so I think it will help you to try to focus on it. Okay, now listen. The C is equal to A cross B. We have to understand A cross B and we have to put determinant method. So C vector would be determinant I cap, J cap and K cap. I am putting it 1, 1, 1 and b is would equal to 2, minus 3 and 4. We are writing only coefficient of this I, that is 1, that j is 1, k is also 1. A vector first we will write, and b vector I will write, that is the 2, coefficient of I, coefficient of j is minus 3, and coefficient or magnitude we can say, and k is a 4 we are writing. Now we have to solve, that is equal to I, first we have to multiply 1 into 4. Keeping this from it, you will see I am not taking anything from this column and from this row. I am just multiplying 1 into 4 and minus 3 into 1. That means 1 into 4 minus 3 into 1. I am writing it. This is the I. So I we will take positive, j we will take negative, and k we will take positive. I am repeating again. I we will take positive, j we will take negative, and k we will take positive. This is alternate we have to put it. Okay. Now this is the I cap we have calculated. Now go for j cap. So I will write minus. Why minus? It's the minus. Okay. Now again we will do the similar thing. What we will do, from here I can remove it, and we will see here, from this column I will not take anything, from this row I will not take anything. That means I have to multiply like this. Okay. So 1 into 4 and minus 2 into 1. That means 1 into 4 minus 2 into, I can write like this. Similarly for k cap I will write. So for k cap you will see, I am just removing this again. You will see for k cap, from this row nothing is taken, and from this column we will not take anything. So just multiply like this. That is the 1 into minus 3 minus 2 into 1. That means 1 into minus 3 minus 2 into 1. That is a very simple thing, we are doing it. So just calculate little bit, you will understand. C cap, C vector, that would be 4 plus 3, that is equal to 7 I cap. Here you will see that is equal to 4 minus 2, that is the 2, and this will become minus, this is minus 2 j cap. Here the minus 3 minus 2, that means minus 5, that means minus 5 k cap. And please reply everyone, up to here you are understanding or not understanding, please. Okay, Dinesh and I, Pyari, Abhi, Vicky, Tommy, please reply in the Surendra. Are you understanding what I am solving? How to calculate this, all this stuff? Good. Good morning, Dinesh, Surendra. Good morning. Okay. Now try to focus on the board. This is a very basic concept we have to apply in the talk, and we will see the different type of problems. Okay, I am starting from very scratch. You will understand how to calculate the C vector, that means A cross B. That similarly we have to do here R cross F. So we have to find the torque. We need R cross F, then only we can go for it. Understanding? So I am moving to the next. Okay, Shurendra, you are Gayatri. Okay, I understood. Now try, just tell me you are understanding or not. Okay, please reply. Now see very simple example. One very first example, you will see it. If I say the R vector, if I is given to you, R vector is equal to suppose I cap plus j cap plus k cap. Okay, and this is the force vector, that is equal to suppose 2I cap minus j cap plus 4k cap. I'm writing it. My question is very simple, find the torque. We have to do it. So similar calculation we have to do. That means I have given to you the torque is equal to R cross F. Will you try it? I'm just giving some time to you. Please try it. If you want to try it, I just given you idea how to calculate the cross product. Okay. Okay. Please try it, beta. Gayatri, Anoy, Dinesh, Pyari. Okay, please try it. Okay, please try it. I'm just waiting for your calculations. Okay, I will take some water. Try it. Please try it. Everyone is trying. Okay. I'm solving. If you whatever your answer, you can check it. Okay. Please listen on the board. We have to do the same calculation here. So you will write torque is equal to here determinant method I, J, K. We will write it. What is the R? That is equal to 1, 1 and 1. This is 2 minus 1 and this is a 4. We have to put it. Now we have to write the torque. So first, before that, we have to do the some calculation. We will put positive, negative, positive. I am writing the torque. Torque is equal to first is I. I would be 1 into 4 minus 1 into this. 1 into 4 minus 1 into 1. Okay, this is the I. This similarly you will say for J, but this is minus. Now you will do J 1 into 4 minus 2 into 1. 1 into 4 minus 2 into 1. This is the K. Just wait. Plus K. K would be 1 into minus 1 minus 2 into 1. From here, what you can see, just focus on the board, that torque would be equal to how much? 2 minus plus, this become 4 plus 1, that is equal to 5 I cap. 4 minus 2, that is equal to 2, and this is a minus, this is a minus 2 J cap, and this would be minus 1 minus 2, that is a minus 3 K cap. Okay, this is a Newton meter. This is a very simple torque. I am writing it. Up to here, everyone is understanding? Please answer it. You understood this question? How to solve it? Good or not? Your answer is correct. Okay, good. Tommy, good. Gayatri, Abhi, please reply. Dinesh, understanding? Everyone? Okay, now this is a very basic concept I have given to you. I am giving one more question, you will understand. Example 2. It will help you to understand the concept little more. Suppose if I say find the torque about A due to force F if position vector of A is 2I cap minus J cap plus K cap, and force acting is F is equal to I cap plus 3J cap Newton. This is a meter. We have to find the torque. This is given to you. This is a similar question I am giving just for your study hour time. When you are at home, you can try it and it will help you. The similar question, A vector is given to you, R, that means A vector means position vector, that means R vector is given to you, and force vector is given to you. Try to solve and you will find the torque. Can you calculate in your study hour time? I am just leaving for you this question for your practice. Okay, I am moving to the next type of problem that will help you to understand. Okay, now come to the next slide, you will understand. Now you can take a screenshot also. Very simple question, you will see it. Example 3. Now listen carefully, it will help you. This is the just schematic diagram. It is not correct diagram, I am telling you already. So don't focus on that part. Suppose this is a origin and I'm taking here one point is A. Okay, this is a position vector R1. Okay, on this position vector you will see there's a one force is acting. This is a F. Okay, and there's a one more point is there. You can see this is point is B. This point, and this position vector is R2. Okay, if I join both points, if I join this both points, this become a R vector. Okay, and now question is very simple. R1 is given to you, R2 is given to you, F is given to you, and we have to calculate the torque about A or about B or about O. What I told you in the example 1, that type of question already you can see in the PYQ. This type of problem also you can see in a PYQ. So try to understand, you will learn it. So now I am giving the data that F is equal to, suppose if this is I cap plus J cap plus K cap. I am taking very simple data to understand. And R1 vector is given to you, suppose 2I cap minus J cap plus K cap. These all diagrams are just schematic, don't go for exact diagrams. This is a meter. And R2 is equal to, suppose 3 J cap plus K cap plus 4 K cap. I am writing it, this is the meter. Now question is very simple. Find the torque due to F, first about A, second about B or O, I can say, third is about B. These are three simple questions we have to understand. When you learn this question, it will help you to solve everything. Okay, there is one of the finest question that will clear your concept. Try to understand. When we are saying कि about A, we have to find it. About B, we have to find. About O, we have to find. Now try to listen carefully. At which point the force is acting. Try to understand at which point the force is acting. Force is acting at A only. And we want to calculate the torque about A only. That means what is the R vector now? A point is same at this point, and at the same point I am applying the force. That means R becomes 0. Because R is nothing anywhere. Na? Because this is the point. At this point I am applying the force. And we want to calculate the torque about also this point. That means what is the R vector? There is no perpendicular distance between force and this point. This is the point and this is the force. If they are here, that means perpendicular distance would be something. But now R becomes 0. That means what is happening? Now torque becomes 0. So that means if I ask you what is the torque about A, so no need to calculate directly, you can say the torque is equal to 0. That means for A, you can say the torque about A is equal to 0. Nothing has to be calculated because here what is happening? R is 0. There is no R vector. Okay. Everyone is understanding up to here. Please reply. And now good. Your answer is correct. Dinesh. Please reply. Gayatri, Tommy, everyone, please reply it. Okay, so this is the very basic thing. So we understood that this is a torque is equal to 0. But now come to the about O. We have to calculate. About O. About O, this means this point. So now between F is acting at A, O point is here, O to A, there is the R vector, that is nothing else, R1. How much? R1. So R1 we have to apply, force we have to know, then we can calculate directly what with the torque. The second calculation I am doing, the torque about O is nothing else, R1 cross F vector. R1 cross F vector, R1 is given to you, F is given to you, put it, you will get the answer. What is R1? R1 is given to you 2I cap. Okay, I am just writing the torque calculation here. I cap, J cap, K cap. You will see and that is equal to 2 minus 1 and 1, and force is equal to 1 1 1. That's so simple. So torque about O would be equal to, this is a plus, this is minus, this is plus, and I, this would be minus 1 into 1 minus 1 into 1. Very simple. The second would be minus j, j would be 2 into 1 minus 1 into 1. Simple. K would be how much? K would be 2 into 1 minus 1 into minus 1. You can see, and the torque about O would be equal to, this is the minus 2i cap, this would be minus j cap, and this would be 3k cap, and this is a Newton meter. This is a very simple calculation, we can do it. Up to here, please tell me you are understanding, everyone is understanding or not? Torque about O. Okay, simple calculation what we have learned in the previous question. The similar calculation we have done here also. Dinesh, Tommy, Anoy, Gayatri, everyone please reply. Understanding? Okay, good. Now you are understanding. Now come to the third point. Third part of this question, that is the important thing. We have to learn about, we have to calculate. The third point, about B we have to calculate. About B, B point is here. So from B to A, because force is acting at A, we have to find this R vector. So how to calculate this R vector? So we have to understand very simple by using the triangle law of addition. By triangle law of addition, you can say R2 vector plus R vector is equal to R1. R2 vector plus R vector is equal to R1. I can write it, then only I can solve. So I can say R2 vector plus R vector is equal to R1. We want to calculate R vector, so R would be R1 vector minus R2 vector. So from that we have to calculate R, then we can calculate the torque. So what does R become? The R1 is given to you, R2 is given to you, just subtract it. What you will get? You will get my 2i cap minus 4j cap and minus 3k cap. And this is a meter. We know the R vector. We know the force. Force is also given to you. That is equal to I cap plus j cap plus k cap on a Newton. And using this, we can calculate the torque about B vector. Torque about B. Can we calculate? If you can calculate, please reply, and it would be your actually study hour type work. You can calculate very easily. Please reply. Tommy, Dinesh, Anoy, Gayatri, and many other persons in the watching the videos. Please try to answer it. Understanding? Please. Good. Now try to learn. Now we are going to focus on the next type of problems. That is also important. But before going into much in detail a different type of problem, I will tell you the few things about the torque, because now you know the basic mathematical expression of the torque. Now we have to see what is the meaning of the torque. We have to understand very simple thing in our daily life. From that you can understand what is the meaning of torque. Suppose this fan in the room or in your room also, you can see the fan is rotating. That is only due to torque. If torque is removed, definitely it will stop after some time. That torque is supplied by actually electromagnetic forces. We will learn, okay, and 12th class is one chapter. We will learn about it. But for right now, we know that there is a torque. If you open your room gate, that is also due to the actually torque. If I take one very simple thing, you will understand. Suppose you can see this in my hand, there's one water bottle is there. If I take this lid, I want to open it, so I'm just also applying here torque. Without that torque, it cannot be opened. If I want to close also, then also I have to apply the torque. So these are few basic things. If my hand is rotating, so these there also we are applying the torque. So torque is very important concept in our daily life. Okay. So whenever the rotation comes into the picture, So there the most of the chances are there that their torque is present is there. Okay. So what is the meaning of torque? Torque is nothing else. There is actually rotational analog of force. Whatever the force is doing in the we can say mechanics for translational motion. In translational motion, that means particle is moving in a straight line or linear path. In that path, if particle is moving, so there the actually force is required for to provide the acceleration to stop it, okay, or to accelerate any body or to actually stopping any moving body. So for that the force is required. The force is very important concept there. The similar analog in the rotation. If body is at rest, we want to rotate it. If fan is stopped now, if I put it switches on, it will start to rotate. Then what will happen? There would be a torque would be there. If I want to stop it, then we have to close the switch or we have to put some resistive force or resistive torque, then it will stop. So torque is important. The car is moving from one place to another place. That torque is also there. That is provided by actually what? Friction force. We will see. So there are different aspects we have to learn. So torque, the rotational analog, very simple word, very simple definition if I give you in the mechanics. So rotational analog of the force in the rotation is nothing else torque. The similar concept provided by the force in the translation motion, the same concept is provided by the actually torque in the rotational motion. Now one thing we have to understand this. The second thing is the torque is not just like a force. If we apply the force, if the net force acting on a body, net external force acting on a body is equal to 0. Listen carefully what I am telling. If the net external force acting on a body is equal to 0, that definitely I can say the acceleration of a body would be 0. That means it cannot accelerate because the force is equal to 0. But when we are talking about the case, if there the force is acting, so the torque can be 0 or non-zero or both can be possible. So we have to understand, then only we can answer it. So I told you already the torque is equal to R cross F. Mathematical expression I have given you, few examples I have given to you, and that type of question you can find in the paper also. But we have to learn the more about the physics. Physics is not mathematics. Okay. So now we have to learn about the torque. When we are talking about the torque, torque is equal to R cross F. This R vector is also very important. I have given one example so that you understand the concept. And force is also important. And angle between them is also important. Because when we see R, when we actually say R cross F, R cross F means R into F into sine theta. That means theta is playing some role here. Okay. I'm repeating again. The torque is equal to R cross F means R into F into sine theta. If R becomes 0, definitely torque becomes 0. That means if force is applied at the same point about which we want to calculate the torque is equal to 0 because R is 0. One thing. The second thing is that if I say F is equal to 0, if force is not applied on the body. Okay, listen carefully what I am doing. I am not saying the net force, I am saying the force is equal to 0. What is the meaning of net force? I will tell you, don't worry. If force is equal to 0, then also torque would be 0. Because R into F into sine theta, if F is 0, definitely torque is 0. The third concept is that theta. Theta means sine theta is 0. Sine theta becomes 0 when theta is equal to 0 degree or 180 degree. I am repeating myself, try to understand. If I say if theta equal to 0 or theta equal to 180 degree, at that same time you can say clearly that the torque is also equal to 0. These three terms are very, very important. That will give you idea when torque can be 0. Okay, I will show you some examples. You will understand one by one by using the examples. Okay, but before that I will give you some more idea about the torque. We call sometimes torque is also moment of What is the moment of force? Meaning rotational effect of force. Rotational effect, just like we call moment of inertia. We call in translation inertia. Translation motion, we are interested in inertia. And that inertia is given by actually what? Mass. Okay. Similarly, the moment of inertia given by mr square. Okay. So that is the m is also important and r is also important. That means position of this mass or distribution of this mass across the axis of rotation and position of axis of rotation. So that is also important. Similarly, here also when we are talking about the torque, that is here also it is important to see rotational effect. That means R is also important, force is also important, theta is also important. Torque is, by the way, actually what? Vector quantity. Torque is not a scalar quantity. Okay. Now few more things I will tell you. When you see the dimension of the torque, dimension of torque is force into distance, means perpendicular distance. We are saying. So force into perpendicular distance, that is similar ml square t minus 2. And when you go for energy or work, in that case also you will find the same dimension, because that is also what? Force into displacement, that is the work done, or energy, that is also ml square minus 2. That means dimension of work or energy or torque all are same. I am repeating again. The work energy also having the dimension ml square t minus 2. When we are talking about torque, it is also having the same dimension ml square t minus 2. So both are having same dimension. But remember one thing what I am telling. The physical quantity which are having the same dimension, that does not mean that they have the same physical significance. Maybe their physical significance is totally different. Here also you can see the same thing. When we are talking about that work or energy, they are almost same thing. That means energy can be converted into the work. When we are doing some work, the energy can be changed. So this is a very simple thing. But when we are talking about torque, torque is totally different. Okay. Torque is the rotational effect of the force or analog of the force in rotation. When we are talking about this thing, in that you will learn one more concept, what I am telling you. Torque is a vector quantity, but work and energy also is a scalar quantity. Work and energy is scalar quantity, and torque is a vector quantity, totally different. Next, when we are talking about the torque, torque is measured in Newton meter. We do not call joule. But when we are talking about the work or energy, they are measured in joule. These are few basic differences in the work, energy and torque. And from that you learn one very important concept. That means the physical quantity having the same dimension does not have the same, maybe they do not have the same significance, physical significance. I will give you some more idea, you will understand. Coefficient of friction, mu, that is a dimensionless quantity. Refractive index, also dimensionless quantity. Magnetic susceptibility, also dimensionless quantity. If we talk about the angles, maybe plane angle or solid angle, okay, they are also dimensionless. But all are having the different physical significance. So be clear about it. If this question is asked to you, the quantities, the physical quantities having the same dimension will also have the same physical significance. So answer is no. Not necessary. Maybe or may not be. Just like if work and energy having the same physical significance, but the torque is also having the same dimension, that does not have the same physical significance. So we have to be clear about it. So I told you the very basic idea about the torque, how the torque is measured, or how to basic idea. We can see some more question, but definitely I will not extend the class, because after some time you will have some classes, your bio classes also, botany and zoology. So I'm keeping the class up to here, and the remaining questions numerical we will see in the next class, if I will be continue. Maybe some other teacher from tomorrow onward maybe will continue, and they will have their different topics. So don't worry about it. Try to learn what I have given to you. If you have enjoyed my all 4-5 days classes, and put some positive message so that I will, if I read them, definitely I will enjoy your messages. Okay, so put it there. Okay, thank you so much. I enjoyed your classes. Thank you so much. Bye bye.
Hello students, good morning. I am your KVR sir, Sri Chaitanya College, Gosala, Vijayawada. Today is very interesting and important topic that I have selected is photosynthesis and particularly numerical questions. In the coming classes, we will discuss different concepts of the photosynthesis, but right now we'll see only numerical part of the photosynthesis. Okay, done. So this is our discussion part is photosynthesis in plants, numerical questions. And the first question is very simple question. This is the PYQ, previous year question. So what is the concentration of CO2 in the atmosphere approximately? The correct answer is 0.03. Correct answer is 0.03. So 0.03 is the correct answer. It is constant atmospheric CO2 concentration is 0.03. It is very interesting and very important question for the competitive exams. It is being asked in many examinations. Was it clear? I am going from simple questions to the complex questions. Done. So let us we see the next question. And of the total amount of the water absorbed by the plant, actual percentage of the water utilized during photosynthesis is 1%. All these are previous year questions, only 1%. Majority of the water, that is around 85 to 90% of the water will be transpired and stored in different parts of the plant and utilized by the different parts of the plant. But right now, percentage of the water that is utilized directly in the light reaction of the photosynthesis is 1%. It is standard and fixed answer. Clear? And the third question here is how many quanta of light required for the reduced 1 molecule of CO2 and produce 1 molecule of O2 in green plants of photosynthesis. So 1 molecule of O2, you know very well, this is a reaction center 1, that is P700. This is reaction center. So first of all, I will take a reaction center 2 P680. This is reaction center 1 P700. Then it will absorb 2 photons of light, and 2 electrons will be excited to pheophytin. This is when there is a light, then only electrons will be transported. Hence, it is said to be uphill transport. What do you call it as? Uphill transport. From pheophytin to reaction center, as it is shown, that is downhill transport. So again, 2 photons of light. First it is go to FRS, redoxin reducing substance, and then it will reach FD. So 2 electrons are excited. 2 electrons are excited. The 2 electrons from P700 will reaches to peridoxin. The 2 electrons that is required to P700 is supplemented by pheophytin. Now the P680 requires 2 electrons that can be substituted by OEC, oxygen evolving complex, in which Mn and Cl will be there. So of course this topic is deleted from the portion, but the question can be asked, which of the following mineral elements are essentially required for the photolysis of water? Clear beta? Mn and Cl. Now water molecule will split H2O to H plus 2E minus plus half O2. Half O2. So was it clear? So you can observe here 1, 2, 3, 4. 4 photons of light. 4 photons of light. How can you define the photon of the light? The quantum of the light energy that is required for the excitation of the outer valency electron in the chlorophyll molecule. Clear? One photon of light excites one electron. Here for excitation of two electrons, two photons of light is required. Here for excitation of two electrons, two photons of light is required. For 2 plus 2, 4 photons of light. How much oxygen is released? Half O2 is released. So then it is very easy for the liberation of one O2, 8 photons of light is required. 8 photons of light is required. So beta, you should have to remember one statement from the textbook, that is the PS1 and PS2 named after their discovery but not according to their function. That means that first functioning is PS2, two electrons will be excited and reaches to the primary acceptor, that is pheophytin. From the primary acceptor to the reaction center PS1, that is called downhill transport. From reaction center to primary acceptor, this is uphill. Clear? One more reaction is there here. NAD plus NADP plus is converted into NADPH2. The primary reaction center to primary electron and proton acceptor NADP plus, that is downhill. Anyhow, what this question is clear. How many quanta or photons of light is required for liberation of one oxygen molecule? That is 8 photons of light is required. Here we can make one more question. What is that question? If one O2 requires 8 photons of light, in photosynthesis 6 O2 is released. So how many photons of light is required? 48 HV. 48 photons of light is essentially required for liberation of 6 O2 in the light reaction of photosynthesis. Was it clear? Do you have any doubts? Hello students, please show me thumb finger. Are you getting me? My voice is audible to you? Was it clear? Hello students. Then let us go for the next question, that is in pigment system 2, the trapping center of light energy is in pigment system 2, the reaction center part is P680. Pigment system 2 P680. So this is the one previous year question we should have to remember. P680 is the reaction center. So in pigment system 1, what is the reaction center? That is P700 is the reaction center. This is also PYQ. And next question, number of ATP and NADH2 molecules required to reduce 6 CO2 molecules in C3 plants. Beta, very clear. So 1 CO2 So in dark reaction, we have 3 steps. We have 3 steps: reduction, regeneration, carboxylation, reduction and regeneration. So it is most frequently asked question in photosynthesis. What is the most crucial event in the dark reaction? Most crucial event in the dark reaction is first step, that is carboxylation. Clear? So in dark reaction, you have reduction and regeneration. For reduction to ATP is required, 1 CO2 reduction to ATP is required, and 2 NADH2 is required. So in total 3 ATP plus 2 NADPH2 are required for the reduction of 1 mole of CO2. So if I go for same calculation, 6 CO2, 3 ATP into 6, that is 18 ATP plus 6 into 2, 12 NADPH2 are required to reduce 6 CO2 molecules so to 1 glucose. So in C3 plants, how many ATP and NADPH2 are required for the reduction of 6 CO3 molecules? Then it is very easy. For 1 CO2, that is 3 ATP and 2 NADPH2, then multiply with the 6, 3 6 are 18 and 2 6 are 12. So that is 18 ATP and 12 NADPH2 is called as reduction power or reducing power. Reduction power or reducing power. You know one statement. What is that statement? Dark reaction depends on the products of light reaction but not on the light directly. Dark reaction, that is biosynthetic pathway or Kelvin cycle or pentose reduction pathway, or you may call it as C3 cycle, that depends on the products of the light reaction for the reduction of the CO2. Hence, ATP plus NADPH2, ATP plus NADPH2 together called as reducing power or assimilatory power. Assimilatory power or reducing power is synthesized in the light reaction. So one more question is given as a statement question. What is that statement question is? What is that statement question? Dark reaction is misnormal. Dark reaction is misnormal. Why it is misnormal? It also takes place in the light time. So dark reaction requires ATP plus NADPH2. Until up the moment availability of ATP NADPH2 is there, then dark reaction may take place in the light as well as in the dark. And you should remember one more point here regarding the dark reaction. Dark reaction. So if the question is asked in section B like this, if light is stopped, supply of light is stopped, what happens to the plants? And so that will be a question. So dark reaction first takes place, then that is interrupted after some short of time. So till the moment total ATP and NADPH2 available in the system is used up, then dark reaction will stop. And in Sri Chaitanya, last year long-term students, we do have one question that is also again beautiful. What is that question is? Generally dark reaction depends on products of light reaction. Now the question is, light reaction depends on the dark reaction for. I repeat my question, light reaction depends on dark reaction for ADP plus NADP plus ADP plus NADP plus. So light reaction depends for this on the dark reaction. Was it clear? Shall we go next slide? Number of ATP and NADPH2 molecules required for reduction of 6 CO2 molecules in C3 plants. C3 cycle or Kelvin cycle takes place in C3 plants, C4 plants, C3 cycle takes place in C3 plants only, C3 and C4 plants, C3, C4 and CAM. CAM, crassulacean acid metabolism. CAM plants are also known as succulent plants. Succulent plants like aloe vera, bryophyllum, Chenopodium and Portulaca oleracea. Leaves are fleshy. Such kind of plants, CAM plants, C4 plants, C3. So what is common in all plants? C3 cycle is common. In all plants, C3 cycle is common. Just now we revealed that for C3 cycle 18 ATP plus 12 NADPH2 is required. So he is asking in C4 plant. C4 plant that is required in bundle sheath cells. Bundle sheath cells. Now the pyruvic acid that is produced on oxidative decarboxylation of malic acid have to move to mesophyll cells. Pyruvic acid have to converted into, this is phosphoenol pyruvic acid. For this 12 ATP are required. 12 ATP are required. So regular requirement of ATP for the reduction of 6CO2 plus 6CO2 is 18 ATP plus 12 NADPH2. But in addition, C4 plants requires extra 12 ATP. Then 18 plus 12, 30 ATP plus 12 NADPH2 is required for reduction of 6 CO2 molecules in the C4 plants. So this is excess of 12 ATP is required. Excess of 12 ATP is required. This is again 2016 APMT question. The excess of ATP required for C4 plants in comparison with C3 plants synthesized from cyclic photophosphorylation. Cyclic photo. Could you now understand? Could you now understand? The question given is additional ATP required for C4 plants in comparison with C3 plants can be synthesized from. It means that he is asking about only ATP synthesis. You can see only ATP is synthesized in cyclic photophosphorylation. Cyclic photophosphorylation synthesize ATP. So extra ATP required is 12 ATP. Regular ATP required is 18. 18 plus 12, 30 ATP. 30 ATP, 12 NADPH is required for 6 CO2 reduction in C4 plants. Then tell me for 1 CO2, that is 5 ATP plus 2 NADPH2 is required for the reduction of 1 CO2 in C4 plants. Was it clear? There are 4 questions we have discussed so far now. The first question is, how many ATP are required for the reduction of 6 CO2 in C3 plants? Then the answer is 18 ATP plus 12 NADPH2. Then the next question is, in C4 plants, how many required? 30 ATP plus 2 NADPH2. And another question we have studied here is, the question is slightly changes, but answer is constant here. Number of ATP and NADPH2 required for the reduction of 1 CO2 molecule in C4 plants. In C4 plants will be 5 ATP and 2 NADPH2. This is the correct answer. Was it clear? Was it clear, students? Shall I go for next page? Number of ATP and NADPH2 required for reduce 1 CO2 molecule in C3 plant. Just now I discussed 18 ATP plus 12 NADPH2 is required for the reduction of 6 CO2 molecules Then tell me by 6 and by 6. So 3 ATP plus 2 NADPH2 are required for the reduction of one CO2 molecule in dark reaction. 3 ATP plus 2 NADPH2. Just now we discussed this. Just now we have discussed that. One CO2 molecule reduction requires, one CO2 molecules requires, can you understand how many ATP? 3 ATP plus 2 NADPH2. Was it clear, students? Shall we go for next slide? Total number of photons of light required to release 6 O2 molecules in light reaction. I told you already, this is pigment system 2, light harvesting system LHC2. This is pigment system 2, that is P680. This is pigment system 1, P700. That is light harvesting center 1. So here 2 photons of light, here 2 photons of light. Then one water molecule is undergo photolysis. Then H2O give rise to H plus 2E minus plus half O2. So 4 photons of light, half O2. Then 8 photons of light, 1 O2. Then 6 photons of light. 1 O2 requires 8 photons. And 6 O2 requires how many? 6 8s are 48 photons of light. 6 8s are 48 photons of light is required for the liberation of for the release of 6 O2 molecules in the 3 plants. Was it clear? Was it clear? So total number of, in the same type, so the question can be asked in different way. Total number of photons of light required for the release of 6 O2 molecules, 48 photons. Total number of photons that is required to operate non-cyclic electron transport in light reaction, that is again 48 photons. Total number of photons of light to required for the photolysis of 12 H2O molecules, that is again 48 photons. So for 1 O2 8 photons, for 6 O2 that is 48 photons of light is required. Was it clear? Then you should have to know one more thing here. So what is a photon? What is a quantum? Quantum of the light energy required for the liberation of one electron from the outer valency of the chlorophyll molecule is called as photon. Clear? This is the question being asked on light reaction. So let us go for the next slide. Number of ATP molecules required for regeneration phase of RUBP during synthesis of one glucose molecule. I told you already. So 1 CO2 reduction reduction 2 ATP plus 2 NADPH2. Regeneration 1 ATP totally. So for reduction of 1 CO2 molecule, in total I told you 3 ATP plus 2 NADPH2 is required for 6 CO2 molecules. 6 3s are 18 ATP plus 12 NADPH2 is required in C3 plants for reduction of 6 CO2 into 1 glucose. Clear? But now read the question. Number of ATP molecules required in regeneration phase of RUBP during synthesis of 1 glucose molecule. Regeneration phase. 1 CO2, 1 ATP. 6 CO2, 6 ATP is required, and the answer is this. 6 ATP, if I talk about 6 CO2, 6 into 2, 12 ATP in reduction and 6 ATP in regeneration. Together it is 18 ATP. So he is asking about regeneration only. Then the answer is first option, that is 6 is the correct answer. Was it clear? Was it clear? Could you now understand the numericals? Say yes. Respond me. Sana. Respond me. Dinesh. Swami. Dinesh, Swami, Vicky, please respond me. Is my voice is audible? Are you understand? Do you understand my questions and explanation, or do you have any doubts? Please say yes or no. Please respond. Done. Let me go ahead. Next question. How many molecules of water is needed for green plants to produce 1 molecule of hexose sugar, reduce 6 molecules of CO2? I told you already. So I told you already, in light reaction, 12 water molecules will undergo photolysis of water. Each water 2 electrons. So 12 water, 24 electrons plus 24 protons plus 6 O2 will be liberated. So this is one question, this is another question, this is another question. 3 questions are there. So the first question is how many water molecules will undergo photolysis during light reaction? That is, answer is 12 water molecules. Second question is how many electrons are passing through the electron transport system in non-cyclic electron transport? That is, 24 electrons are being transported. So another question, how many protons are generated towards to the lumen side on oxidation of 12 water molecules? That is 24 protons. And the fourth question, if 12 water molecules are undergone photolysis or oxidized, how many oxygen molecules are liberated? That is 6 O2. So how many molecules of water is required? In the correct answer is 12 molecules of water is required for the reduction of 6 molecules of CO2 in direct reaction. Because we write it in the reaction itself, 6 CO2 plus 12 H2O give rise 6 O2 plus 6 H2O. This is the basic reaction we will write in photosynthesis. So for reduction of 6 CO2, how many molecules of water is to be oxidized? How many molecules of water is to be oxidized? The 12 molecules of water have to be oxidized, because 12 molecules of water is oxidized. So according to Robert Hill reaction, so in intact plants, what is the immediate protonic acceptor? What is Robert Hill reaction? In the presence of a strong hydrogen acceptor, the chlorophyll molecules can split split water molecule and liberate oxygen. This is a Robert Hill reaction. According to the Robert Hill, in intact plants, what is the strong and powerful hydrogen acceptor is NADP plus. So how many NADP plus is required for dark reaction? 12 NADPH2. 12 NADPH2 is required for dark reaction. NADP plus how many? 12. So 12 molecules of water have to be photolyzed so as to produce 24 electrons and 24 protons to convert the 12 molecules of NADP plus into 12 molecules of NADPH2. Was it clear? And now the sixth question you can ask here, the ratio between water molecules oxidized in the light reaction and NADPH2 produced in the light reaction. Ratio between water molecules oxidized is 12 and NADPH2 is reduced is again 12. That is 1:1. Was it clear? Was it clear? Next question. The ratio between ATP utilized in the reduction and regeneration step of the dark reaction. I told already students, 1 CO2 for reduction, 2 ATP and 2 NADPH2 is required. For regeneration, 1 ATP is required. So he is asking what is the ratio between utilized reduction and regeneration? 2:1. 2:1. Or let us go for 6 CO2 molecules. Reduction, 6 2s are 12 ATP. Regeneration, 6 1s are 6 ATP. So for the reduction of 6 CO2 molecules, so ratio between ATP utilized in the reduction and regeneration. Could you now understand this question? 12:6. 12:6. 12:6. Ratio between ATP utilized in reduction and regeneration steps of the dark reaction. 12:6. We don't have option. The correct answer is in reduction 12, in regeneration 6, total it is 18 ATP is required. Correct answer is 12:6, that is 2:1. 2:1. Students, could you now understand this question and answer? So I repeated this answer 2 times so as to have your notes perfectly for the upcoming questions. Clear? Shall we go to the next question? Photosynthetic active radiation, that is also called as PAR. Range of the PAR represent the following wavelength. This is the question asked in APMT 2004. In NEET 2004, this question is asked. What is the range of photosynthetic active radiation? It is very important. That is 400 to 700 nanometers of light. In this light only photosynthesis takes place. Less than 400 nanometers of light or more than 700 nanometers of light, there is no chance of photosynthesis. Hence we call it as photosynthetic active radiation. Range of PAR is 400 to 700 nanometers of light. Was it clear? It is the standard question and PYQ, previous year question, APMT 2004. So what is PAR? 400 to 700 nanometers of light. Was it clear? Standard question and standard answer. Shall I go for the next question? And if 5 molecules of RUBP involved in direct reaction of photosynthesis in a C3 plant, how many PGA molecules will be produced? Done. So have a look here. In direct reaction, 6 moles of Ru15 bisphosphate is attached with 6 moles of CO2. So in the presence of Ru rubisco, because rubisco has dual nature, depending on the relative abundance of carbon dioxide and oxygen, rubisco can act as carboxylase as well as oxygenase. This is the dual nature. So 6 Ru15 bis molecule, 6 moles of Ru15 bisphosphate and 6 moles of CO2 in the presence of an enzyme rubisco will turn into 12 molecules of PGA, phosphoglyceric acid, which is 3C into 12, 3 into 12, 36, 6 into 5C, each is a 5C, 30 plus 6, 36. Was it clear? Was it clear? But the question asked is, say, if 5 molecules of RUBP are involved, 5 Ru15 bisphosphate, then add with 5 CO2, then tell me the activity of rubisco. Here it is 6, it is 12, then it is 5, it is 10 PGA molecules can be regenerated. 10 PGA molecules can be regenerated. Are you getting me? Was it clear? And the answer is second option, that is 10 PGA molecules. Was it clear, students? Shall I go for the next slide? I am going to the next slide. So percentage of photorespiratory loss in C3 plants. Percentage of photorespiratory loss in C3 plants. It is very important. This is 25%. Now what happens? What happens here is 6 moles of Ru15 bisphosphate is each is a 5C is ready to accept 6 moles of CO2, but because of peculiar activity of the rubisco, instead of 12 moles of PGA, phosphoglyceric acid, the Ru15 bisphosphate, by accepting oxygen, by accepting 6 oxygen, it will undergo photorespiration. 6, each is a 5C, do remember 6 moles. Then this Ru15 bisphosphate, 1, 2, 3, 4, 5, a 5 carbon substance, organic pentose sugar, will be broken into 2 pieces. One is 3C, another one is 2C. 3C is phosphoglyceric acid, 2C is phosphoglycolate. Phosphoglycolate. How many moles? Here it is 6. Here it is 6. 6 3s are 18. 2 6 are 12. 18 plus 12, 30. 5 6 are 30. Was it clear? So now 6 moles of PG are slowly getting converted into 3 moles of PGA. 6, 2 into 6, 12. But here what is this? 3 into 3, 9. So totally how many are recovered? So out of the 12 PGA expected, so 9 PGA are formed. 9 PGA are formed. Was it clear? Nine PGA are formed. Was it clear? Was it clear, students? Now, so let us have a look here. This is the answer is 25%. Was it clear? 25% loss will be there in a photorespiratory loss. The fixed carbon will be oxidized. The rest of the numerical questions will be discussed in the next class. For this class, I would like to take a pause. Thank you very much. Have a good day. and I'll meet you with the next lesson in the next class. Thank you.
Good morning. How are you all? Are you going through the things or simply you have been watching the class and spending your time? You need to go through, you need to be in touch with the subject, otherwise, we may be unable to remember the things. So, the other day I was discussing about the cockroach external morphology, and in the 2024 NEET exam, we got 2 questions asked from cockroach. Structural organization has 4 questions. Out of that, cockroach, we have 2 questions being asked, right? So, we cannot give less importance to the topic. It also has a major role. So, when you go into the details of anatomy of this animal, right, like for example, digestive system, arthropods are somewhat advanced than compared to annelids because we have glands outside the gut in arthropods. In annelida like Ferretima, it has the digestive glands are present only in the gut. You don't have glands outside, but in arthropods you will have glands outside the gut. For example, if you take cockroach, cockroach has a pair of salivary glands, right? So, you have glands outside the gut and they are well developed than compared with annelid. So, in cockroach, the alimentary canal or the gut is divided this is divisible into 3 regions being called as foregut, midgut and hindgut. Right, the 3 regions, the 3 broad regions in the animal. Foregut and hindgut, these 2 are lined by cuticle. Inner layer is cuticle in case of foregut as well as hindgut. So, in NCERT it mentions about the foregut, but also hindgut is lined by cuticle, complete foregut and complete hindgut. Midgut, this is not lined by cuticle. Midgut is lined by endoderm. You don't have ectodermal covering, but here you will find only endodermal lining is present. So, cockroach, as you know, it is an omnivore, right? Omnivore, we have the offline being starting from the 3rd, right? The 3rd Monday onwards we will have the offline classes in the VAIDYAH 2025 program. Okay, you can motivate your friends and others about the details of the program and how you the people who are there in Chaitanya, they know about the way we handle the topics, okay, where we give the details of the topics and all that. You can tell your friends about the details so that they can also come. We have regular classes offline from Monday onwards. As the animal is an omnivore, it will eat all kinds of food material. So, naturally when it is passing through the gut, there is a chance of gut inner layer being damaged, which is protected by cuticle in foregut and hindgut. But in midgut, you don't have cuticle or ectodermal layer. So, here it is protected by a special membrane produced by itself. It produces a membrane called as peritrophic membrane. Okay, midgut produces peritrophic membrane around the food material. As soon as the food material comes from foregut to midgut, right, that food material is surrounded by a membrane all around called as peritrophic membrane. So, this is a porous membrane. This membrane is a porous membrane. What do you mean by porous membrane? Porous means it will have pores, so that enzymes can go inside and they can act on the food material, and digested food also can come out and it can be absorbed in the midgut. Right, through the pores you will find digestive enzymes of the midgut will go and act on the food. At the same time, after the digestion, the digested food also can come out and it get absorbed. Right, and the membrane will be protecting the lining of the midgut from any damage being caused by the food material. Right, that is about the things you should remember about the three regions. And between the foregut and midgut, there are 6 to 8 blind tubules. They are blind because they are opening only on one side. There are 6 to 8 blind tubules present at the junction of foregut and midgut, being named as gastric CK or hepatic CK. These are called as gastric or hepatic CK. Now, their function is they release certain enzymes. They release some secretion helping in digestive process. So, they are present at the junction of foregut and midgut, right. Now, where do they open? Do they open into foregut or do they open into midgut? Right, they are present at the junction of foregut and midgut, fine. But where do they open? Do they open into foregut or do they open into midgut? Respond. Yeah, they actually open into midgut, right. They are present at the junction of foregut and midgut, and these hepatic CK, they will be opening into midgut. So, the digestive secretions, they are released into the midgut. Similarly, at the junction of midgut and hindgut, at this point we have 100 to 150 structures present in the animal. At this junction, the cockroach is having 100 to 150 thin filamentous yellowish colored there are 100 to 150 structures which are yellowish in color. They are thin and filamentous structures being named as the Malpighian tubules. These Malpighian tubules are present in around 6 to 8 bundles. Okay. Now, the question again is, where do they open? They are present at the junction of midgut and hindgut, no doubt, right. Now, where do they open? Do they open into midgut or do they open into hindgut? Right, just like hepatic CK, as they open into midgut, here also you will find Malpighian tubules open into hindgut. Okay, these structures, they open into hindgut. Malphizian tubules, as you know, they will be collecting the nitrogenous waste from the blood or from the hemolymph, and it get released into the first part of the hindgut called as ileum. Okay. So, these things you need to remember related to the gut as such, having three structures connected with it, and where do they open. Now, what is the function of foregut? Function of foregut. Foregut will be helping in the collection of the food material. It takes the food material from the mouth and it enters into pharynx, then it comes into the narrow esophagus, then it will be stored temporarily in crop. Foregut, this will include the regions called as pharyngeal region. Mouth leads to pharynx, that leads to a narrow esophagus. Esophagus leads to crop. Crop leads to gizzard. Right? So, these are the regions are present in the foregut, which will be helping in receiving the food material which is being cut by the mouth parts and it is mixed with the saliva. Right? That structure is swallowed through the mouth, enters into pharynx, passes through esophagus to crop, and crop actually store the food material. The food material is temporarily stored in crop, and gizzard in cockroach is highly muscular, right? The outer layer it is provided with the strong muscles, inner layer it has cuticle. As I said, foregut is having a lining of cuticle, right? That cuticle is provided with teeth like structures. Inner layer is the cuticle. This cuticle is projected into teeth like structures which will be helping in grinding the food material. So, gizzard acts as grinding mill. Gizzard in cockroach will act as a grinding mill where the muscular and chitinous teeth will be helping in grinding the food material into fine particles. So, foregut is helping in collecting the food material, storing the food material and grinding the food material into fine particles. Whereas the midgut is the region where the digestion process gets completed in the proximal part, and in the distal part of the midgut absorption takes place. Okay, in the midgut what we will find the changes is the process of digestion get completed, digestive process get completed and absorption takes place in this region. In the proximal region digestion get completed, and in the distal region you will find absorption takes place. And hindgut is comparatively wider than midgut. This structure is comparatively wider. Wider means it will have the large lumen compared to midgut. Midgut is a bit narrow, having a small lumen. When it comes to the hindgut, it is wider because the lumen is somewhat larger than midgut. So, hindgut will be helping in absorbing the water from the waste material. Hindgut absorbs the water from undigested waste, as well as it receives the nitrogenous waste from Malpighian tubules. So, even from the waste that is coming through the Malpighian tubules enters into ileum, and it will be reaching the colon and rectum, where it will be absorbing the water from both kinds of waste. You need to remember, undigested waste and nitrogenous waste. The large intestine, okay, this is somewhat having the wider lumen. The hindgut helps in absorbing water from undigested as well as nitrogenous waste. So, these are the things you need to remember related to the digestive system, along with the structures connected with the alimentary canal and their functions. Okay. And salivary glands are a pair of glands, as you know, they are being present on either side of the crop, right, and they will be opening outside the body. Salivary duct is present at the base of hypopharynx. So, saliva mixes with the food material outside the body, where the mandibles will be conducting the, breaking the food material that is mixed with the saliva, and it forms a soft ball like structure that the animal absorbs, or it will be pushing it into the pharyngeal region through the mouth. And circulation in the animal, circulation in cockroach is said to be open type. Cockroach has open type of circulation. What do you mean by open type? Absence of blood vessels is open type. What do you mean by open type of circulation? Open type of circulation means absence of blood vessels is open type, right? Not absence of blood vessels. Blood vessels may be present. In open type of circulation, blood vessels may be present, but blood should come out into the cavities or sinuses. Okay, blood should come out of the blood vessels into the open spaces being called sinuses. Then it is said to be open type. So, blood vessels are present. In case of cockroach, we say blood vessels are poorly developed. Absence of blood vessels is not the definition for open type, right? Blood vessels may be present, but they are not well developed, and blood comes out into open spaces. Blood, it will be coming out into the open spaces, or we call them as sinuses. Then it goes as the open type. Okay. Now, circulation can be divided into three structures. One is the body cavity, right? Then blood, and the third is the pumping organ, heart. Okay. So, body cavity in cockroach is called as hemocoel. Body cavity in cockroach is named as the hemocoel. Heme, wherever you get the prefix heme, it refers to blood. Okay, wherever you get the letters heme as the prefix, that means it refers to blood. So as the body cavity contains blood, it is named as hemocoel. Right? Body cavity in cockroach is called hemocoel because it contains blood. That's why it is called as the hemocoel. Okay? So you may have assertion like body cavity in cockroach is called hemocoel, right? A reason statement may be like it is filled with the blood. Then what may be the answer? Assertion is in cockroach the body cavity is called hemocoel, right? Reason I will give you like it is filled with the blood, right? So reason explains, isn't it? Reason explains assertion. So like that the questions may be framed, and to have an idea about the body cavity, try to remember this, it is not given in your books. In the book you don't have the diagram or you don't have details, but if you can remember this diagram, or you can understand the things quite easily. Say this is the body of the cockroach. The body cavity is divided into 3 sinuses. The body cavity is divided into 3 sinuses with the help of the green lines I have drawn here. They are called as the diaphragms or septa. This is called dorsal diaphragm, right? This is called as the ventral diaphragm or ventral septum. So that the body cavity is divided into 3 chambers or 3 sinuses. The upper one is called pericardial sinus because it is having heart. This chamber is called dorsal sinus or pericardial sinus because this encloses heart. The middle one is called as perivisceral sinus because this will enclose viscera. As it encloses the internal organs like your alimentary canal and other structures, it is named as perivisceral, and the lower one is called perineural. Okay, so you may not have to remember all this. You should have an idea how the blood will be flowing in the animal. For that, this diagram will be helping you to understand quite easily. Okay. So body cavity is divided into these 3 sinuses called pericardial, perivisceral and perineural. So heart lies in the upper chamber. Okay, the cavity is hemocoel, it is divided into 3 sinuses, and in this you will find the internal organs or visceral organs all the internal structures can be called as the visceral organs. They are bathed in blood or hemolymph. Blood in cockroach, we call it as hemolymph. Blood in cockroach is called hemolymph, right? So inside the hemolymph, all your internal structures are present inside the blood or hemolymph. That's why they are said to be bathed in blood. This is about body cavity. Then the details about blood in cockroach. Blood in cockroach, as I said, it is called hemolymph because it has colorless plasma. We call the blood as hemolymph because it doesn't have any respiratory pigment. It is just like water, colorless. Okay, blood in cockroach is not white. It's not white in color, it is colorless, right? So colorless plasma has some cells present in it which are called the hemocytes. These hemocytes will be acting as a phagocytic structure. They act like our WBC, where they will be able to eat away the foreign structures and they try to protect the animal from the harmful pathogens. Okay? And blood, it won't contain any pigment. So that means blood in cockroach, it cannot transport oxygen. Blood in cockroach is unable to transport oxygen because there is no pigment. As you know, oxygen is less soluble in water than compared with carbon dioxide. So it may be transporting little amount, but that is not sufficient for the animal. So absence of respiratory pigment is compensated by, how does this absence of the pigment is compensated? It is compensated by well developed tubular system called as the tracheal system. Okay, cockroach has a tracheal system where the trachea will be highly branched tubular structures where they reach each and every corner of the animal. So that cockroach will breathe oxygen directly. We breathe oxygen indirectly. Okay, say for example, if I need oxygen to perform a function here with the help of my hand, right? So I need to breathe air into my lungs. Okay, and in the lungs you will find in the alveoli oxygen should diffuse into blood, CO2 should go out, and that oxygen carried by blood should go to heart, and my heart should pump the oxygen to the region where I require oxygen. This is called indirect. But in cockroach, oxygen goes to tissues directly. Cells will breathe oxygen. Okay, so that is well developed tracheal system and respiration. So blood in cockroach is colorless, that's why we refer it as the hemolymph, right? So plasma is not having any pigment. It has cells called hemocytes helping as phagocytic structure. The third component is heart. Heart in cockroach is a long tubular structure, okay, long tubular and muscular structure present in the mid-dorsal side in thorax and abdomen. Okay, cockroach has the heart located mid-dorsally it is located mid-dorsally, okay, in the thorax and the abdominal region. Okay, say for example, this is the animal, cockroach, right? So this is dorsal and this is ventral. So mid-dorsal means this is the middle of the dorsal side. So exactly in the middle of the dorsal side you will have heart chambers being present. I will give a rough location here. This chamber is having heart. Anteriormost chamber opens into head as the only blood vessel called as aorta. Like this you have 13 chambered heart being present in the sinus called dorsal sinus. Okay, in the upper chamber called as the dorsal sinus you will find the long tubular muscular heart located, which is provided with a pair of apertures called as ostia. Each heart chamber has a pair of openings called ostia. Should remember the name. Ostia will be allowing blood into heart. Blood enters into heart chamber through ostia. Now once blood enters into heart chambers, blood is pumped anteriorly. Blood gets pumped from posterior to anterior. Okay, blood comes to the head sinus, and from the head sinus blood is again pumped back into perivisceral and perineural sinus, and because of the contraction of the muscles called alary muscles, it is again pumped back into the pericardial sinus, then it goes into heart. Okay, so the heart is a long tubular structure This is a long tubular structure present mid-dorsally in thorax and abdomen. So this is a 13 chamber structure. Heart in cockroach is having 13 chambers. So 3 chambers are present in thorax, 10 chambers are located in abdomen. Okay? The 3 chambers are present in the thorax, that means thorax has 3 segments. So prothorax will have 1 chamber, meso will have 1 and meta will have 1 heart chamber. Similarly, all abdominal segments will have 1 heart chamber. And each heart chamber opens into sinus with the help of a pair of apertures called ostia. And you should remember, ostia will allow blood. Ostia are provided with the walls, right? And they allow blood from the sinus called pericardial sinus into heart. Blood cannot come out of the heart into the sinus called pericardial sinus. Okay, so these pair of apertures or ostia are provided with walls. They don't allow blood to come out of the heart chamber, but it is pumped anteriorly into head sinus through the only blood vessel present in cockroach is the aorta. So blood vessels are absent in cockroach means wrong. It has the blood vessel called aorta. That's why we say blood vessels are poorly developed in cockroach. And cockroach is provided with 12 pairs of alary muscles. It is not given in the description, but they are there in the labeling. There are 12 pairs of triangular alary muscles that will be helping in circulation of blood. Alary muscles will be helping in the course of blood circulation. They get attached to the tergum and they get attached to the diaphragm called pericardial septum. They are present like this. The triangular muscles, they get attached to the tergum through the narrow end, and the broad end, it is attached to the septum called the dorsal septum or pericardial septum. Okay, so the muscles called alary muscles, they help in pumping the blood. Okay, sorry. They help in the circulation of blood. That is, they will be raising this septum called pericardial septum, or the septum may be lowered or raised up. so that they create pressure on the perivisceral, or they cause pressure in the pericardial, so that blood will be entering into the sinus, and from there it can enter the heart chamber. So the course of circulation is not included. Just remember that alveolar muscles will be helping in circulation of blood. So those are the three things related to circulation in cockroach, right? One is the body cavity, where the cavity is called hemocoel because it contains blood. This cavity is again divided into chambers. That is not required. You can have an idea like pericardial, perivisceral and perineural. And second, about blood. Blood in cockroach is referred to as hemolymph because it is colorless. Okay, as the plasma is without any pigment, it remains colorless, and blood contains the cells named as the hemocytes that are phagocytic. And the third is about the heart being located mid-dorsally, right? And it is present just below the terga or the tergite. 3 chambers are there in thorax and 10 in the abdomen. So each heart chamber has a broad anterior end and a narrow anterior end and a broad posterior. You can have idea. Heart is present like this. I'll draw 2 heart chambers to give you an idea. It is in the shape of the funnel. They are funnel shaped. This is the narrow anterior end, this is the broad posterior end. So each chamber is provided with a pair of openings here called as the ostia. Through these ostia, blood enters into heart. So once the blood enters, it gets pumped anteriorly into the head sinus and then into the perivisceral and perineural. That is the tubular heart, which is 13 chambered, and animal has 12 pairs of alveolar muscles helping in circulation of blood. Okay, that's about the circulation in the animal. And a brief also about respiration. It is not discussed much in the book. Respiration in cockroach is carried out with the help of the branch tubes being called the tracheal system. Respiration is carried out with the help of the trachea. The trachea are the long tubes which are lined by cuticle, which will be extending almost to all regions in the body. So details are not given in the NCERT. Trachea are the tubes which will be branched, and branches will be ending as tracheoles. Trachea, when they branch, finally they end in small tubes being named as tracheoles. These tracheoles are intracellular. Intra means inside. They lie or they present inside the cells, right? So it is the tracheole that actually helps in diffusion. As they lie inside the cell, diffusion of gases, that is intake of oxygen and giving out carbon dioxide, takes place in tracheoles, which will be ending in the cells or present in the cells. So trachea will be opening outside. They open outside through small apertures being named as spiracles. Spiracles are also named as stigmata, okay, which are present on pleura. What are pleura? Respond. Cockroach exoskeleton is present in the form of plates, right? The plate present on the dorsal side is called tergite or tergum. The plate present on ventral side is called sternum or sternite, and the plates present on the lateral sides are called the pleura or pleurites. So spiracles are present on the lateral plates. Say this is tergum, this is sternum, right? Say these are the lateral plates which are called the pleura. So this pleura has the aperture being called as spiracles. Spiracles are present here on the lateral sides. Spiracles are valvular, or a book uses the word called, they are provided with the sphincters. That means spiracle opening and spiracle closing is regulated. When the animal wants to take in the air or when the animal wants to expel the air, it regulates this opening or aperture. So spiracles are regulated by sphincters, and cockroach has 10 pairs of spiracles. Cockroach is having 10 pairs of spiracles, and these spiracles will be helping in intake of air into trachea. From there it will be branched and finally reaches the tissues with the help of tracheoles, and tracheole will be helping in exchange of gases. Okay, this is what is given in the animal, textbook, but slightly some more details, that is, these 10 pairs are distributed, 2 pairs in thorax, 8 pairs in abdomen. Spiracles, 2 pairs are present in thoracic segments. In the early class where we discussed about the morphology, I told you spiracles are absent in prothorax. So the 2 pairs are present, 1 pair in mesothorax, 1 pair in metathorax. So that means prothorax is not having spiracle, right? Prothorax is without spiracle. Similarly, prothorax is without wings. Cockroach is provided with 2 pairs of wings. First pair is present in mesothorax, second pair is present in metathorax, that is 4 wings and hind wings. So prothorax is without spiracle, prothorax is without wings. 8 pairs of abdominal spiracles, they are present in first 8 segments. First 8 abdominal segment, they have spiracles. This is the additional information. Okay, as you know, thorax is having 3 segments and abdomen is having 10, that means 13, but spiracles are only 10. So naturally the questions may be asked like where they are actually located. Okay, so their location is 2 in thoracic segments and 8 in abdominal segments, first 8 abdominal segments. Okay, and the breathing process is helped by the contraction of muscles called dorsoventral muscles and the dorsal longitudinal muscles, that will be helping in inspiration and expiration. So they are not included. And remember, the tracheal system is well developed and it is reaching all the tissues or the cells directly, and cockroach breathes oxygen directly. We breathe indirectly. Okay, right? So anything else, any doubts? Do you have any doubts about this? We'll discuss also the other things tomorrow. That is, you may be worried about the reproductive system, that's also being important, related to various structures and also their role in carrying out the function. Anything else? Right? Thank you. Have a good day.